In today's video, we are covering 8.6 complex numbers and polar coordinates. I am going to skip the warm-up today, but it is there if you want extra practice on graphing. Now, I'm going to go right into some vocab. We are going to be starting with complex numbers. There are two different forms we can write these in. Excuse me, let me get that on a better pen setting. There we go. A complex number in rectangular form. This is the first form of a complex number. Rectangular form is how you have seen it in the past. We write it as a plus bi, where a and b are both real numbers, and I is equal to the square root of -1, as you have seen. The real part of z is the number a. The imaginary part is the number b. So there's a real component and an imaginary component to this. So if I have a number like 3 plus 2i. The 3 part is the real part. The 2 is the imaginary part because it's captured with the I. Now let's talk about what conjugates are. Two complex numbers are called conjugates. This is also some vocab we have seen before in our last unit especially. If their real parts are equal and their imaginary parts differ in sign. So 3 plus 4i, the conjugate of that would be 3 minus 4i. The complex conjugate of any a plus bi is going to be written with that, we call it z bar. It's z with that little bar over it. And that would, of course, be a minus bi. Now, some properties of complex numbers that you should be familiar with. If I have two numbers and we're saying that they are the same, two complex numbers are equal, then the real parts would have to be equal, a and c, and the imaginary parts would have to be equal, so b and d. How do we add or subtract numbers? All you do is you combine real and imaginary parts separately. So you combine like terms, basically. So I have 3 plus 4i minus 2 and minus -5i. 3 minus 2 will give me the real part, plus 4i minus -5i will give me the imaginary part. So we end up here with a 1 plus 9i. Beautiful. Let's take a look at multiplication. Multiplication is the same as with polynomials, so you just FOIL it out. But don't forget that if I is equal to the square root of -1, then I squared will lift off the square root and be equal to -1. And this will help to simplify. Go ahead and FOIL that out and choose the correct answer on the Edpuzzle. And after you FOIL that out, hopefully what you got was a 6, an 8i, and a minus 15i. And then you got a minus 20i squared. I'm just going to focus on this part to the left. A minus 20i squared becomes a minus 20 times a -1, so it turns into a positive 20. So we end up here with 26 in total, and then we get a -7i for the imaginary component there. And hopefully that's what you got as well. Now, when we divide complex numbers, you don't actually divide anything, but because you have an I in the denominator, and that's technically a radical, we're not supposed to leave that. So dividing really just means rationalizing. So you multiply both the top and bottom by the conjugate of the denominator. And what that's going to do is that is going to clear the fractions with you. Conjugate of the denominator. Which one is the conjugate of the denominator? The conjugate of the denominator was the 1 plus 3i. So that means you are going to FOIL out a 1 plus 3i on both the top and the bottom. On the top, that should give you a 2, an I, a 6i, and a 3i squared. In the denominator, what you get is a 1, a plus 3i, a minus 3i, and a minus 9i squared. Now, when you are simplifying this, remember the 3i squared becomes a -3, and the -9i squared becomes a positive 9. The I squared basically just changes the sign. So on the top, you get 2 minus 3, so -1 goes with your 7i. On the bottom, notice the 3i and the minus 3i canceled out. That has to happen. If that did not happen, then you didn't multiply it by the correct thing, or you didn't multiply it correctly. We get 1 plus 9 to give us a 10, and this is a rationalized version of the original problem. let's go to the next page. So on the top of the next page, we're going to talk about powers of I. What's interesting about this is we get a little pattern. I to the power of 1 is just going to be called I. Nothing exciting. It's square root of -1. We know that. I squared is -1 because it lifts off the square root. So if I take I cubed, I'm going to multiply I and I squared. So I times -1, this is going to become a negative I. And I to the 4th is positive 1. Then your pattern repeats. I to the 5th, you can think of it as I to the 4th times I. I'm using I to the 4th because I to the 4th is positive 1. So this becomes just 1 times I, which means I to the 5th is I, and I've restarted my cycle again. I to the 6th is -1. I to the 7th is negative I to the 8th is another positive 1. In fact, if your power is a multiple of 4, it will equal positive 1. What is I to the 9th? I to the 9th should come out to be a positive I, and then I to the 10th will be a -1 again. So this pattern will continue to cycle, and every time the power is a multiple of 4, it reduces to a positive 1. Let's go through a couple simplify problems here. In the first one, you're going to add those two. Go ahead and choose the right answer. And the answer that you wanted to choose was 8 plus 4i. You're just adding like terms, so that one's not too bad. In the second one, you are going to FOIL out this first part first, and then you'll subtract the I at the end. So first, FOIL all this. What you get when you FOIL that out is an 8, you get a 28i, you get a -12i, and then you get a -42i squared. Don't forget, there is still a negative I at the end of this. So once you combine everything, remember -42i squared turns to a positive 42. You should end up with a 50 and a plus 15i. Should be the final answer when you add all those up. And then for part C, since I have an I in the denominator, which is kind of like a root in the denominator, what I want to do is multiply by the conjugate of the denominator to both top and bottom. So you're going to go ahead and multiply that out and simplify. I'm going to skip the work here, do it yourself, but the answer you want at the very end is -17 plus 20i all over 26. If you didn't get there, pause this video and make sure you can get there. Now, why do we care about all this? We did all this in an algebra class, so why are we doing this now? Because what we want to do now is get ourselves to deal with these in terms of a polar form. So what we're going to do is we're going to go to a complex plane. A complex plane does not have an xy axis. It has a real axis and an imaginary axis. And we're going to plot all these points. So point A, the -2 is the real component, so you go left 2 to here. The +3 is the imaginary component, so you go up 3, and there is your point. Part B has no real component, so it just goes up 3 on the imaginary axis. C, similarly, goes down 2 on the imaginary axis. D has no imaginary component, so it goes 2 to the right, but does not go up or down. E is going to go over 1, up 1. And then F will go left 1, down 2, and be here. So we have done this probably in an Algebra 2 class. This is just plotting points. I'd like to emphasize, again, that all of these points are in the form called rectangular form, where we have a real component and an imaginary component. Our goal is not to work with this form, which we've done in the past, but to convert all of this to polar form. So good notes here. To write a complex number in rectangular form, we write a plus bi. This is what you have done in the past. To write it in polar form, you write it as r cis theta. R cis theta. That is a shorthand for r cos theta plus r sine theta I. R cis theta means the R gets applied to the cosine and the I sign. So the C is for cosine, the IS is for I sign, and then the R gets applied to both of them. The textbook uses a different form as well that's not as popular. They use this RE to the I theta. So if you see the textbook, right, RE to the I theta, you can just take the R and the theta and you can convert it to R cis theta and then use it our way. You'll just have to do that on some of the homework problems because that's how the book uses it. So just make sure you kind of recognize that correspondence. So let's go ahead and take 2 points in rectangular form and change them to polar form. I'm going to start by plotting Z1 on a complex plane. Z1 is negative 2i, so it's down 2. Here it is. If I want to change this to R cis theta, what I need to find is the radius, which appears to be 2, and the angle, which appears to be at 3 pi over 2. And that's it. You write it as 2 cis 3 pi over 2. Very similar to what we did when we converted to polar coordinates last class, but now we're writing it in an R cis theta instead of R comma theta. Same type of work though. Let's take one that's a little bit harder. Negative 2 plus 3i. So we're going to go left 2 and up 3. So I believe that'll put me in quadrant 2. Left 2 and up 3. If I go left 2 spaces and up 3, here's my point up here. The R is going to be the hypotenuse. So I'm going to find that with Pythagorean theorem. We'll get square root of 13. The theta is going to be the quadrant 2 angle that gets me to that triangle. So to find theta, you're going to do tan inverse of y over x. Your calculator is going to give you negative 0.98, which is in quadrant 4. So you're going to add pi to it to move it to quadrant 2. And the theta that you get is 2.16. Once you have r and theta, you just write it as r root 13 cis theta, 2.16. That's all there is to it. Same type of work we did with regular polar coordinates, but our formatting is different because this is a complex number that we are dealing with now. Let's say we want to go the other way. Let's say we have the r and the theta and we want to put it in rectangular form. So let's write it as r cis theta. And if you want to figure out what that is, I don't even have to graph it. I want to put this into a plus bi form. And I know that r cis theta is short for r cos theta plus r sine theta times I. And I know how to do all this. I can evaluate. Cos of 3 pi over 4 is a negative root 2 over 2. Sine of 3 pi over 4 is a positive root 2 over 2. And that's your answer. I'm going to write it at the end as negative 5 root 2 over 2 plus 5 root 2 over 2i. The way it's written to the right is also perfectly fine.